At a minimum, your centripetal force has to equal your gravitational force. Right? So your centripetal force would be mv squared over r. Your centripetal force would be mg. Right? Masses cancel out. You get v equals the square root of, and that gives you the minimum velocity. Right? Okay? Cool with that? Everybody cool? Okay. So if you're going faster than that, you'll complete the loop. Okay? Alright? Let me see.
Oh, we have to quiz tomorrow, don't we?
It's a V.
I need to draw this.
Oh, why'd we go down?
I don't think you have to
Wait.
see on the
Remember yesterday you got
So,
Yeah,
I got a fairly cool new toy. Literally, you're the first class to ever see this.
Oh my God.
Okay, no, I started playing with it.
Class.
I started playing with it very. Remember?
I saw it.
Okay. So this valve opens up and you can equalize the pressure.
Oh my God, why would you?
No.
So
It's the PVT.
this is HPA, which stands for what?
It's what?
What's the PA?
Oh, Pascal.
Pascal.
Yeah.
Pascal.
Hectopascal.
Hectopascal.
What?
Which is a
What
weird
the
thing.
heck?
He's a
Okay.
Straight up, man.
Don't worry. It's just a weird number. Now, conveniently at the bottom, there's a temperature probe.
Really?
Okay?
Oh my God.
That shows right now at 21.8 degrees Celsius.
Indeed.
So I've equalized the pressure, so
Yes.
it's 0, even though it's really not. We have an atmospheric pressure. So this is what we call gauge pressure. So the gauge pressure shows 0 because but it's just relative to this scale. of 0.
14.9.
In reality, there's 14.7 psi, pounds per square inch pushing on it. But we basically zeroed it and said, hey, we're going to look at it from an equilibrium perspective like this. So I'm going to turn this down. What's going to happen to the volume? Decrease. Am I going to do work?
Yeah.
Yes.
See.
I'm going to do work.
So,
So,
work equals
well, right now we're at like 22 degrees Celsius. I'm going to slow this down. Okay?
You're changing the volume.
What's going to happen to the pressure?
Go
It's going to go up. What do you think is going to happen to the? I'm going to hold it down here. Okay? I'm not going to like wrap my hand around it. I'm just going to hold it down here. What should happen to the temperature?
Go up.
Go up.
See.
Why?
T goes up, T goes up.
Listen, the particles when they're smashed.
Whoa. Stop.
Okay.
Time out.
Shark time.
Time out. What if, technically, to give the kids Skittles from an outside source, I'd have to heat it up.
Yeah.
So what could I do to heat it up?
Pressurize the skill.
No.
I'd touch it.
Yeah, if I just wrap my hand around it.
Shoot them with
Okay? If I just wrap my hand around it,
Temperature goes up.
Oh my God.
we're going from 22.3.
Wow.
We were at 22.
Oh my God.
So the temperature went up.
See.
Okay? Right? Why?
Because
you're adding.
What was actually happening?
You're
your atoms
adding
colliding with glass.
more collisions.
Particles.
Hold on.
Time out.
How in depth do you want it, Mr. Burkamp?
Okay. Photon.
Oh.
Yeah.
No.
Skittles. We like Skittles more.
Photons in the story. Because something had to carry that energy in there, right? So my hand had a higher temperature than the gas inside. So Mother Nature tried to equalize things out. So basically what happened is that photons went from my hand. Now, speaking of photons, how can you determine the energy of a photon?
I don't remember.
Do we have to know this?
I'm just generalizing. E equals S HF. Right? Now, you're not going to have to know the calculations, but remember, what determines what you see in terms of color?
Frequency.
Oh, the energy. Red has lowest energy, violet light has the highest energy,
Oh,
right?
yeah.
So as frequency goes up, energy goes
Because it's like
up, right?
Right.
But the speed of light or any wave equals what? Wavelength times frequency.
F lambda.
Okay? Oh, old school optics, right? So, why do colors still look the same even though they pass through black?
Energy
The
same.
energy doesn't change because the frequency doesn't change.
Frequency no change.
But if you go through glass and it has an index of refraction of 1.8,
And sign.
It's over to
oh no, that's that.
Slow down.
If n equals 1.8 and the speed of light in a vacuum is 3.0 times 10 to the 8th meters per second,
V equals C over N.
how are you going to get the new velocity in the glass?
By
C over n is going to get you the new velocity. Is the new velocity going to be bigger or smaller?
Smaller.
Than 3.0 times 10 to the 8th.
Smaller.
Smaller. Okay. Now, that new velocity is still going to equal wavelength times frequency. But the frequency stays the same.
That means lambda went
lambda
down.
changing.
So if my velocity decreases, the only way that happens is if your wavelength becomes smaller. Okay. So when you're measuring temperature, you're basically measuring the kinetic energy of the system. You're measuring how much energy these particles have. So that temperature went up to like 23.1. Okay? It was at 22.4. So I wrapped my hand around it. My hand had more energetic photons. Passed through the glass wall of the cylinder that you could not see. Couldn't see the photons going through. They start to interact with the nitrogen and oxygen molecules inside. They go, hey, we got some extra energy. The nitrogen and oxygen go, cool, okay? Thanks for the Skittles. Start to bounce around a little bit more, okay? So by wrapping my hand around it, there was a subtle change in pressure. The pressure went up a little bit. Temperature went up. Now, I'm going to open up that valve, kind of re-equalize everything, make that go back to 0. Temperature was at 23.2. Okay? So now, what I'm going to do is I'm going to push this down. I'm going to compress it. Okay? Am I going to do work?
Yeah.
Why?
Force
over distance.
I'm exerting a force over the distance. So we started at torque 23.3. Okay? So volume's getting
It's
smaller.
increasing.
That's 20.
And what's happening to the pressure?
It's
Pressure's going up, right?
Yes.
But the temperature
Also goes up.
Goes up.
also goes up. Okay?
How hot can you get it? in there?
Temperature's going up. Now, why is the temperature going up?
Because
Keeping
all the
harder than our
particles are hitting
teeth.
each other
Oh,
harder.
they're bouncing.
Okay.
That's why.
More
It's
fission.
like the children with Skittles. You put them in a small room, they're gonna fight each other. Like, hit each other.
Hit each
Okay.
other.
If you
Like
put
land.
it
So-
you're gonna start fighting.
That's a little bit violent.
Like UFC 300.
So my temperature went up to 23.6. Okay? If I compress it even further, I can get it, it's like 23.8. Okay? Now, if I let this sit long enough, what's going to happen to the temperature?
Room temperature.
Equalize.
It's going to go back to the temperature. Because then it's going to lose that energy. It's going to equalize out across that glass. So, let's talk pressure volume graphs. So, volume has to be in cubic meters. Pressure has to be in newtons per square meter, otherwise known as Pascal. So, if you have a horizontal line like this where the volume gets bigger, what do you call that?
Isobaric.
No,
Isobaric.
Isobaric.
There.
Because what's staying constant? Pressure.
Okay, now we're
If you have a vertical line, Isovolumetric.
Isothermic is the last one.
And then if you have this, you have isothermal. Okay? Now, what I just did was not an isothermal line. Why? Temperature went up. I could do this, but I'd have to do it slowly where I could let all that temperature kind of equalize out. Now, I will give you these equations if you need them. Okay? And the big ones are delta U equals Q plus W, and also equals 3/2 NR change in temperature, right? Okay? If you need those, I will give those to you. Q plus W is actually on your equation sheet. The 3/2 NRT, I can't remember if that is or not. But if you need that, I will give this to you.
Is that change in T?
Huh?
Is that change in T?
Yeah, 3/2 NR delta T. So, if you have an isobaric expansion, okay? Let's just think isobaric expansion. Volume's getting bigger. So if you look at PV equals nRT. So pressure's going to stay the same. Pressure's going to stay the same. But what's happening to the volume?
Down.
Volume is getting bigger.
Yeah, never mind.
What's going to happen to N and R?
They said constant.
Nothing. So for that to work, what has to happen to the temperature? Temperature has to go up. So Q is going to go in, going to be a positive number. I'm going to dump energy into the system, right? Right? Or put energy into the system. So if I were to put energy into the system, okay, as that goes across, energy is going to go in. Isobaric. Volume is going to get bigger. So what's going to be the sign of my delta T?
Positive.
Positive. The temperature had to go up.
Bigger minus smaller.
Yeah, bigger minus small, right? So I'm going to have a positive delta T. So that means with the positive delta T, delta U, and remember delta U is the change in all of the energies of the system. We don't ever ask you, say, hey, Burkamp, hook me up to the delta U probe. It don't exist, okay? We can measure pressure, we can measure temperature, we can measure volume. There's no way to directly measure U.
What does R
So, here's the point.
Yeah, I know, but
We can calculate delta U, right?
yeah, I know,
think
but
so,
yeah.
there's something-
And delta U is going to be a, so I'm going to have a positive delta U. Okay? I'm putting energy into the system. Is work going to be done by the system?
Yep.
Yes.
Or is work going to be done on the system or by the system?
Wait, hang on. On the system. Has to be.
By the system.
By the system.
How?
Why?
There's a force that is expanded.
Yes, work is being done by the system. It's making the volume get bigger.
You had to do
Right?
work to make the volume.
Yes. So work has to be done on it to make the volume smaller. Work is done by it to make the volume get bigger. Right? So, because the fact that this is basically a horizontal line, what does the area underneath that line represent?
I don't know.
Work. Because you have newtons per meter
Pull out the
squared
numbers, bro.
times cubic meters, you get newton meters, which is
Work.
Okay.
Wait, Burkamp,
What?
can you go over and think about like work
Wait,
being
what?
done by it?
Okay, if work is being done by a system, you're increasing the volume. If work is being done on a system, the volume gets smaller. Okay? It's all about preposition. Now, because this looks like a rectangle, and the area represents work, remember there's the equation that work equals negative P delta V.
Wait, what is this before?
This is work on an isobaric process. Okay? And the reason that it has to be isobaric is because on a pressure volume, it's just a rectangle. Okay? So it's just length times width. That's all it is. Okay?
I'm not sure.
The negative sign in front just makes it consistent with work being done or work being done by a system, or on or by. Now, in this situation, I've got some pressure, I don't care what it is. If I'm going across like this, I'm going across like this. I'm going across like this. My final volume is bigger than my initial. So my sign of my delta V is going to be a
Positivo.
so work is going to be a negative number. So my delta U has to be a positive number. True?
Yeah.
So Q plus W has to be a positive number, but we just proved that work is a negative. So my Q value has to be and bigger than my work done. So in this scenario, I'm leaving OP $100,000 in my estate. But what does she have to do with some of the money?
Give it to her sister.
Give it to me.
Pay taxes.
She work with it.
Invest it. I don't know.
Pay taxes.
Hey, Berg, in order to speak of the analogy was Natalie first.
This is probably like. Put it in the
Hey, and
same
AP
spot.
Physics
No,
was made by
that
Berg
was the
Brothers.
ball rolling down a hill.
Oh,
Do not pay attention.
That's mafia, bro.
It's not
Hey, you can't be using that.
You have to pay the energy model.
You can avoid
If you need anything wonky like the equation for the velocity of the satellite, what is the equation for the velocity of the satellite?
V equals
M
Berg.
over something, something, something.
Oh, or not.
Oh, it's right.
It's rated
I said that. It's right. I said that. Hey, but I said most of it. I said that.
Okay?
What about
I said the
periods?
R.
What about like periods?
Now-
What about VM?
My fault.
Is that mass the mass of the satellite
Earth.
or the mass of the
Earth.
Earth?
I think the mass of the
So
Earth.
really, you said the radius, and I said
Where's the radius measured from?
From the
From the
center.
center of the earth to the center of the sun.
Center of the Earth out to the satellite. Okay?
anyone can say it. Not anyone can say
I
it.
beg of you, do not discount what's going to happen in chapter 21 with that.
Hey, what's that supposed to mean?
Okay? Know those equations I gave you the answer to all of those problems.
I don't know.
Spend some time on that. Okay? Chat.
Are we gonna have to memorize any equations?
Oh, yeah.
All the equations.
If you need, well, I'm not going to give you forced parallel and forced normal.
Wait, I looked at the big dog sheet.
Yo.
I'm not going to give you AC equals 4 pi squared r over t
No, but
squared.
why she don't see?
But something weird like this, I will give you.
Or is this the-
Okay?
That's what
So we don't get the
What
big
about
dog
for
sheet.
like
You get the
Frequency.
equation sheets you've had
Periods.
since you
Wait, we
started
don't.
teaching.
Wait, why don't we get these ones?
You don't get that.
Average
Which
length.
one do you
what
get?
about like
The
the
same ones you've had.
Right,
What's
what
the
about
buoyancy
equation for
situation?
I would know
We're not.
optics,
No,
convex,
because we didn't learn
concave,
it.
lenses, and mirrors.
Oh, yeah. Physics honors didn't learn it.
Right? I would know that.
Yeah.
Louise, did you have a question?
What about the equation for frequency and period?
That's
Hey,
on the
The square root
equation.
stuff.
That's on the.
That's on the sheet.
There's so many ways for frequency.
I know what he's talking about.
You know what I'm talking about.
Okay, I know Saudi people have to go.
Wait, do we need? Sorry.
What?
Mike.
Keep
Figured it
go.
out. I believe it.
What?
What about like inertia, like the big I and that
If
stuff?
you need any moment of inertia equation, I will give it.
Thank
What's
you,
the
Bird.
equation sheet you just got?
Whatever.
What's the equation sheet you guys have?
Can you help me with
For these three.
Oh my gosh.
I have. Tomorrow, today.